here is your key to your review. I am going to give you the formulas for arithmetic and geometric sequences. You do not get them on the AP exam, but I'll give them to you. Didn't seem to help some of you very much on the quiz anyway. So, all right, the next two questions refer to the following information. So selected values of an unspecified sequence are given in the table above. And it says, if it's arithmetic, what is the value of A? So there's a couple different ways to do this, but might as well just go ahead and use the equations that I have. I need an A sub n and an A sub k, so we'll make this k and this n. So that would make this A sub k and A sub n. That's okay. So I'm going to substitute everything in. This gives me 0.5 is equal to -4 plus d times n minus k, 4 minus 1. So then if I add 4 to both sides, I'm going to get 4.5 equals 3 times d, divide by 3. D is 1.5, which is also my slope. Then when I write my equation, a sub n is equal to a sub k, which is -4, plus 1.5 times n minus 1. And I'm looking for, this would be a sub 3. So a sub 3 is equal to -4 plus 1.5 times 3 minus 1. 3 minus 1 is 2 times 1.5 is 3. So -4 plus 3 is -1. And there you go. All right. Number 2. If the sequence is geometric, which of these could be an expression for the nth term? So I'm going to show you how to do it, but then we're also going to talk about how else you could do it, since it is a multiple choice question. But I'm going to do the same type of thing by choosing, this will now be g sub k and g sub n, and I'm going to use this. So g sub n, which is 0.5, is equal to g sub k, which is -4, times r, which we don't know, to the n minus 1 power, the 4 minus 1 power. And so I need to figure out what r is. Well, it looks like r is just, it's either 1/2 or -1/2, one of the two. Got to figure that out. Even if I don't know how to divide here. So let's think about this. Okay, 0.5 divided by -4. That's a 0.4. Oh my gosh. 0.5 divided by -4. That's equal to r cubed. Okay, so if I want to find r, I can tell by my answer choices, r is either 1/2 or -1/2. Whatever that number is on the left with the decimal and a fraction, it's negative. And if I take the cube root of a negative, guess what I'm getting? A negative number. So A and C cannot be my answers. Now, if I wanted to actually really get this and not just play the game here, another way to look at this is the 0.5 being 1/2. So 1/2, and when I divide it by the -4, I'd actually be multiplying by a -1/4. That's -1/8. And when you take the cube root of that, that's where you get that -1/2. So it's one of those two. Then when we put it back in there, and we have a -4 out front, this would be not a sub n, g sub n equals g sub k, which is -4 times -1/2 to the n minus k power. Your answer is D. All right, moving on to number 3. So we've got this function is in this form. Which of the following is true? So it's talking about growth or decay first. And so to look at that, we look at the B value or the R value. It's R when you're talking about sequences, it's B one here. If this is greater than 1, then it is definitely growth. So it can't be A or B. And it is growth because B is greater than 1, not that B is greater than 0, because if B was 1/2, it'd still be greater than 0. A is also greater than 0. My answer is C. All right, which is an equivalent form. So if I'm going to do an equivalent form, this looks like it's going to be a power to a power. So I've got 2 times 4 to the 2x. That's what they've given me. I can rewrite that as 2 times 4 squared to the x power. So that gives me 2 times 16 to the x. Nothing happens with that 2 there. My answer is A. Alrighty. Number 6. No idea where number 5 went. There is no number 5. What is the value of the limit of h of x as x approaches infinity? So let's look at what's happening with this graph. Okay, so here we have, this is 1/3, so it's being like this, right? That's what it's going to look like because it's decay. And so as we approach infinity, well, here I have, if I don't have any shifts, I have a horizontal asymptote at 0, but this shifts it down to, so if it shifts it down to, then it's actually going to be approaching -2 and not 0. All right, the exponential function k is increasing and concave down. So increasing and concave down would look something like that, which could be an expression for that. All right, well, if I think about like how I could have gotten there, if it looks like that right now, I put it on a graph, increasing and concave down, then it got reflected from something like this, okay, which means that it is definitely starting off as, well, first of all, I'm going to have a negative in front, okay, these two do not have a negative, and it needs to be decay, so although the fraction bar is missing, it would be D. All right, number 9. I really like number 9 because I've had a lot of questions on this. So it says a data set was analyzed with a linear, quadratic, and exponential regression. The residuals for the analyses are given by the graphs above. Based on these, which of the following could be a good model? So good model. And then remember, we want to pay attention to what we're looking at. These are residual graphs for all 3 of these. So just by looking at this, which one is the best? Well, these two definitely have some sort of pattern. So I like this one, this quadratic, okay? Now, there's no way for me, even though I know it's quadratic, there's not enough information on there for me to know how to write my equation. But I know the quadratic one is the good one, and when I look at all my answer choices, there's only one that's quadratic. That's what makes it B. There's no way to know for you to have known that that was the actual equation, other than that's the only quadratic there is. All right, now zombies. Zombie plague is spreading exponentially such that the number of zombies increases by 95% every year. That is scary. If the plague is modeled by Z of t, where t is measured in days, and Z of 0 equals 15, then which of the following could represent Z? All right, so the fact that Z sub 0 is 15, that tells you that's your initial amount, which they all have that, but we can look at that. If I increase by 95%, that means it's going to be 1.95. That is your B. So that's these two here. So I can cancel those out. And then I got to decide, am I going to do 365 times t or t divided by 365? So look, this increases every year. So I need my exponent to represent a year. But I'm measuring in days, okay? So after the first year, I have increased by 95%. So if it's gone 5 days, and I substitute my days in here, because that's what I'm measuring in, 5 times 365 doesn't make any sense. But 5 days out of a total of 365 gives me a fraction of the year. Since this is represented by years and t is now days, then this will give me 1 year there, and my answer is D. All right, this FRQ is non-calculator. I'm going to calculate the average rate of change. That is just slope. And so this is going to be f of 2 minus f of -1 over 2 minus a -1. This is the graph of f, so I can get my information right from here. So f of 2, well, it looks at this first little hash mark, but pay attention to your scale there. That is actually 2 minus f of -1 out here is at 16 over 3, so this is -14 over 3. And it says, using correct limit notation, describe the left and right end behavior. All right, so the limit as x approaches -infinity of f of x, and I know I'm supposed to put f of x because it says f right there, and then I need the limit as x approaches infinity of f of x, and so we're going to negative infinity. As x approaches negative infinity, y is approaching infinity, and as x approaches infinity, y is approaching 0. Now I need to find an expression for this. So really I should have said equation, but this is y equals a times b to the x power, okay? You can use your g sub n stuff, but we have enough information for this. Your a value is your initial amount. So my initial amount right here is 8. B is your common ratio. So if I do here at 0, I'm at 8, and at 1, I'm at 4. So if I do 4 over 8, that gives me 1/2. Then I can just write my equation. F of x is equal to 8 times 1/2 to the x power. All right, so then it says let the function h be defined as this right here, where your expression for f from part C to determine h in that form. So we're gonna have to do the transformations, and then we have to clean it up a little bit. So I've got, that means that h of x is going to be equal to 3 times 8 times 1/2 to the x plus 2 power. Nope. Yeah, x plus 2 power. So that would mean I would go to the left, just like this means I go to the left. All right, so then we have to clean it up. I just wanted an a times b to the x. I got this extra stuff out here. So I can multiply the 3 times the 8. Like, that's okay. I can't multiply the 8 times the 1/2, but 3 times 8, that is going to give me 24 times 1/2 to the x plus 2 power. But then I got to get rid of that stuff in the exponent there. So this is going to become, 24 times 1/2 to the x times 1/2 squared. And then 1/2 squared is 1/4. So that is 24 times 1/4. That's going to give me 6 times 1/2 to the x power. That is my answer. All right, 14. Selected values of the arithmetic sequence and geometric sequence are given in the table above. Determine the value of a sub 4. Show the work that leads to your answer. Okay, so I'm looking for a sub 4. And if it's arithmetic, I can figure out, but I'm missing a 2 here again. So you got to be careful with doing that stuff. So I'm going to use my arithmetic formula. Let me give that to you again. A sub n is equal to a sub k plus d times n minus k. So for this, I'm going to say my a sub k will be 1 a sub 1, which is 18. My a sub n will be a sub 3, which is 13. All right, so I'm just going to substitute everything in there and get my a sub n, which is 13, equal to a sub k, which is 18, plus d, which I don't know, n minus k power. So this is going to give me -5 equals 2d. So d is equal to -5/2. All right, so now I can write my little equation and have that a sub n is equal to a sub k, which is 18, minus 5/2 times n minus 1. So so that when I go to find a sub 4, this will give me 18 minus 5 halves times 4 minus 1. So that gives me 18 plus 15 halves. Oh, plus minus minus. Minus 15 halves. Then I gotta get common denominator here. 36 halves minus 15 halves is going to give me that 21 over 2 equals V. This is 21 over 2. All right. Now I gotta find G sub 1, my initial amount. I can, here's my formula for that. G sub n is equal to G sub k times r to the n minus k power. So I'm going to say G sub k is going to be, oh, not equals. It's going to be G sub 3, which equals 5, and G sub n will be, why do I keep putting equals? Will be G sub 4, which equals negative 10. All right, so I'll substitute them in. G sub n is negative 10. That's equal to G sub k, which is 5, times r, which we don't know, to the n minus k power. So when I divide that, I'm going to get a negative 2 is equal to r to the first. So that is my r. So G sub n then is equal to G sub k, which is 5, times negative 2 to the n minus 3 power. All right, so G sub n, I want G sub 1. G sub 1 is equal to 5 times negative 2 to the 1 minus 3 power. So that's 5 times negative 2 to the negative 2 power. It's going to give me 5 times 1/4. So 5/4 is equal to W. All right, and then I can use either one to calculate what U is. Which one? It doesn't really matter. You can do it either way. I'll just go with the arithmetic right there. So I want A sub n. So A sub n is 3. That's equal to 18 minus 5 halves to the n, which is U, minus 1 power. So if I subtract 18 from both sides, I'm going to get negative 15 equals negative 5 halves times U minus 1. So then if I multiply by the reciprocal, that'll give me 6 equals U minus 1. So U is equal to 7. 7. Those numbers were not that pretty, but you can handle it. I'm not worried about it. All right, the calculator question. All right, a radioactive element X decays at an exponential rate. The mass in grams of X that is present at time t in hours is given in the table above. Using an exponential regression, at what time t will the max of X be 85 grams? Okay, so let's get that in there first. We're going to do a little table here, and so my X values are 0 and 10. My Y values, or my outputs, are 138 and 115. All right, so zoom in and then do my regression. I want that to be an exponential regression. And there's no, because I only had 2 ordered pairs there, there's not a log mode, but remember, if there's log mode, you got to do it. All right, and so I want, it says at what time t will the mass be 85 grams? Okay, so that means that m of t would be equal to 85 grams. At what time is the input or let's see, the time is the input. They gave me the output. Make sure you know which one you got. I have the output, so when I go over here, I can type in y equals, oh Lord, y equals, what was it? 85. I told you to change it to 75, remember? Whoops. We're supposed to change that to 70, or change it to 75 so we can get an actual answer here. 75. So y equals 75. Enter. And then I got to look for that, right? Oh, there it is right there. And looks like my answer is 33.44451. And that would be B. Okay. All right. So again, make sure that you are paying attention to, are they asking you for the input or the output? What is happening there? All right, the population of deer in a forest is modeled by a team of wildlife biologists. 2 function models are created, where T equals 0 represents the year 2020. You also have to pay attention to this stuff. When is the year it represents 2020? That's T equals 0. I'm not going to be putting 2020 into anything. What is the earliest calendar year that the population predicted by the exponential model exceeds that predicted by the quadratic model? All right, so let's go and plot these graphs here. Okay, and so I'm going to type them in. D of T, because I can do that. D of T equals 0.21, oops, my gosh, 0.21 T squared plus 1.72 T plus, it's much easier when you just have a normal keyboard. I'm doing this on my iPad, 6.18. Okay, so I got that graphed. There we go. And then I've got to do E of T. E of T, yikes, equals 5.02 times 1.19 to the T power. Okie dokie, so I have them graphed. I need to zoom out. All right, so here's the deal. Got to know which is which. This said, let's go back and look at what it said. What is the earliest calendar year that the population predicted by the exponential model exceeds that predicted by the quadratic model? So when I look over here, I can see that blue is the exponential. And so here's where they intersect, right? That's important. So they intersect at where the time is 16.937. So that's where they intersect. Right after that, immediately after that, is when the blue exceeds the red. So let's write this down. We got T equals 16.937. Not one of my answer choices, but it does say that T equals 0 represents 2020. So this is how many years after 2020? So this is 2036.937. And so it says, which is the calendar year right after that. This one right here, 2037. Gotta know how to read your data. Okay. This one is also calculator active. All right. Population of bacteria is abandoned. Is in an abandoned container of food T days after it was taken out of the refrigerator. It's given by B of T, where B is measured in hundreds. Select the values of B and T that are given in the table above. So it says that it can be modeled by this quadratic regression. So here's the deal. This was confusing to some people because you can do the regression with the table, but then I gave it to you. And so we're gonna kind of pretend like that's not there because you wouldn't actually be given that. So we're gonna go put this data into our table and come up with our regression equation, okay? So let's mark these out. Let's put our table in there. And I've got 0.5. This is harder to pause while I am on my iPad, so I'm not going to pause. You're just going to have to deal with me. Okay, 2.53, 3.5, and 4. Okay. 4.52. All right, so there we go. I'm gonna zoom in and then I'm gonna hit my regression and I want it to be quadratic. So that is basically exactly what was written there. The difference is this. You may not get the same answer when you substitute things in. So you just want to be very careful and remember that if I export this, I actually have more decimals here when it's in the actual regression than what you can see here or what's being used in your equation on there. And then it just occurred to me, I feel like we've been getting more decimals than this on when we're doing Desmos, and I'm using the app on my iPad and not like the website. So I wonder if I would actually see more of this if I was on the website. So y'all might actually get more of that. But like I said, it's hard for me to pause. So we might have to figure that out in a minute. All right. So either way, I've got this. And so it says, so if I needed to write it down, okay, even though I just marked this out, if I needed to write it down because it tells me to find it, me writing this down is fine. But me writing this down and me using this exactly what I see, those are two different things. If you type this in like you see it, you may not get the same answers that we're about to get. So we want to be careful with that. So it says, find a time t when the population of bacteria is projected to reach 3,000. So that means that I know that B of t equals 3,000. Oh, no, it's, yeah, B of t. Oh, wait. B of t can be Q of t. Oh, that's weird. Okay, either way. 3,000. Okay, but check this out. B of t is measured in hundreds. So if 3,000, I have to divide that by 100. I'm actually using 30 as my number. So be very, very careful there. All right, so if I want B of t to equal 30, that's what I can, now I didn't put the B's and T's in here. These are all in X's and Y's. So I'm gonna say that Y equals 30, hit enter, come over here. This is where they intersect. And I get 5.2692. So T equals 5.2692, and those are days. Okay. Now I need to find the residual value at t equals 2 days, and it says round to the nearest 0.01, which is strange, because remember, correct to 3 decimal places unless you're told otherwise. So you want to be very careful with that. So so remember, residual is actual minus predicted. So the actual is 9.32. And then if I need this at 2 here, I'm going to do x equals 2. X equals 2. And then see, here's one where I probably want to zoom in a little bit. And I get 9.01256, 9.01256. 9.01256. So when I subtract those, so I can do 9.32, so 9.32, and this is where like maybe you did want to do this and go, oop, put it over there so we can see that. 9.32 minus 9.01256. And so it says to round to the nearest 0.01. So what we really get is 0.30744. So when we round, it becomes 0.31. I think this question, I mean, this isn't actually an AP question. Somebody else wrote this and put that kind of stuff in there. But if that's what you're asked to do, you need to be able to do that. So when my residual this is my residual, and it says, does this indicate that your quadratic model is overestimated or underestimated the actual bacteria population, and justify your answer? And so you have to, when it asks you what does this represent, like you could probably tell by looking here that this is the model is an underestimate for that, right? Because it's underneath it. It underestimated it, but you can't say because it was underneath on the model. It's asking you, what does the residual tell you? So you can say underestimate. If I can put that. And then it's because the residual is positive. Okay. All right, so it says B of t can also be done with a linear regression. So it says use the data in the table above to find the values of A and B in L of t. Now look, it's asking me for A and B, and pay attention to what this is. Okay, A is because those have been flipped around before. A is the slope, and then B is the B, but that's not always what it looks like on there. So all you have to do now is go back over here, change this to linear, and then I'm going to cancel those out. Oops, just get rid of all that. And then I'm going to export that. And so when I match this up, this M is where A was, because A was in front of T. So this is 4.4397. So A equals 4.4397. And then the B was the y-intercept, which is 1.0267. Nobody asked me to write an equation. They asked me for A and B, so that's what I'm going to do there. All right. The graphs of the residuals of two models are given below. Based on these graphs, which model is more appropriate for the data? Explain your reasoning. So, and we got to use the real names here. These are both regression models, right? So I would say this one doesn't have a pattern, right? And this is L of t. So this is what they're actually using up here. Remember, this was L of t, and this was Q of t. So we can say Q of t, because that's its name, which is the quadratic model, would be more appropriate because the residual plot for Q of t does not show a clear pattern. Okay, and there we go. And that is it. So make sure that you can find your regressions, like even if it's not given to you, that you can find it and you can use it. You know, you can pay attention to units. You know if you're using the inputs or the outputs. You know how the residuals work. You got this, okay? So do your best.